Andromeda is comprised of an exceptionally enormous cosmic system of stars, like our own Milky Way. Our companion in space is around 2.5 million light-years from the Milky Way. The manner in which we concentrate on Andromeda has changed a great deal since it was first discovered. From using telescopes on the ground to utilizing space telescopes like the Hubble and James Webb Space Telescope, we have made considerable progress. With each new piece of technology, we are reaching new heights and studying the Andromeda universe more deeply, given that we now know more about its structure. 30 seconds. Andromeda has become a standard for studying how galaxies form and evolve. This has given us more information about how the universe functions from a broader perspective. Researchers believe that we need to focus on the connection between Andromeda and the Milky Way to better understand the universe. This is especially important since the two galaxies will eventually collide in around 4 billion years. Despite advancements in research and studies, the James Webb Telescope has recently received a signal from Andromeda that 59 seconds has caused some concern. Researchers around the world are puzzled by this troubling signal, leading to questions about where it came from and what it might mean. The advanced sensors on the James Webb Telescope have detected unusual behavior at the center of Andromeda. The signal sent back to scientists shows results that are significantly different from what has been observed before, which has fascinated researchers globally. The signal suggests that major events are occurring within the galaxy, possibly connected to its 1 minute and 28 seconds. Giant black hole or phenomena that have not been seen before. One of the latest discoveries is that Andromeda's mass may be much larger than that of the Milky Way, changing our perception of the sizes of the two galaxies. The James Webb Telescope has also captured exceptionally clear images and spectra of Andromeda, revealing how new stars are formed and what chemicals they are made of. This new information is crucial for understanding how galaxies have evolved over time and what conditions might be ideal for life. 1 minute and 57 seconds. The telescope's data also shows that Andromeda's dynamic galactic center is becoming more active, which will influence its surroundings and determine its future structure. Scientists are also learning about how mysterious dark matter is distributed in the galaxy by studying its gravitational effects on stars in Andromeda. This will help us better understand how dark matter affects the physics of the universe, as it remains one of the greatest mysteries in astronomy. Recent discoveries made by the 2 minutes and 25 seconds James Webb Telescope have sparked numerous investigations worldwide as astronomers try to understand what is happening in Andromeda. We now know more about the past and future of the galaxy thanks to new data. Andromeda has some amazing features that set it apart from other galaxies in the universe. People are astounded by its size, with new estimates placing its width at around 220,000 light-years, making it one of the largest galaxies in our group and even larger than the Milky Way. 2 minutes and 56 seconds. Its mass is due to its immense size, and it contains around 1 trillion stars, which is more than our galaxy. Researchers are also intrigued by its structure. Unlike most spiral galaxies, Andromeda's central bulge and dense core are surrounded by rings of dust and gas, creating an excellent environment for star formation. One of the most fascinating features of Andromeda is its center, which has a double peak emission, suggesting the presence of a supermassive black hole. This black hole is similar to, but not identical to, the one. 3 minutes and 30 seconds. At the center of the Milky Way, offering valuable insights into these massive cosmic objects. Andromeda is also surrounded by a halo of stellar debris that spans thousands of light-years, composed of stars, planets, and globular clusters. This surrounding space tells the story of how the galaxy formed and its history. The 460 globular clusters found in Andromeda provide crucial information about the early stages of star formation, helping us understand how star clusters 4 minutes and 1 second form and how the universe itself developed. Astronomers are getting closer to understanding the role of dark matter in the grand scheme of things by unraveling the mystery of Andromeda. Yet one lingering question remains. How can we explain the enigmatic nature of dark matter and its impact on galaxy formation? Furthermore, Andromeda has more than 20 smaller galaxies orbiting it, forming its halo structure. Some of these smaller galaxies are losing their stars and gas due to the tidal forces. 4 minutes and 32 seconds. Exerted by Andromeda. This process illustrates how galaxy evolution is dynamic and demonstrates how galaxies grow and interact over time. Looking ahead, The future of the Andromeda Galaxy is closely tied to its collision with the Milky Way, which is expected to occur in about 4 billion years. This collision will not only lead to the merger of the two massive galaxies, but also result in the birth of a new galaxy. Despite the catastrophic nature of the collision, it is considered a normal process by which galaxies evolve. 5 minutes and 3 seconds. And grow. During this event, the gases and dust from both galaxies will combine, leading to the formation of new stars and creating a spectacular cosmic show. Eventually, the collision will result in the creation of a single irregular galaxy. This type of cosmic event, though destructive, has occurred many times throughout the universe's history. The fact that we can witness and understand it makes it even more fascinating. Adding to the drama, the merger of the supermassive black holes at the centers of the two galaxies will further heighten. 5 minutes and 37 seconds. The spectacle. This interaction could cause enormous effects as matter is drawn into the black holes, releasing vast amounts of radiation. This process not only provides insights into how galaxies change over time, but also raises an important question. What will happen to our solar system after the merger? Although the solar system won't be completely destroyed, its trajectory and conditions could change significantly. The orbits of the planets might shift, or they could be ejected from the newly formed galaxy. Scientists are 0609 studying similar cosmic events to better understand how this works and predict what will happen to our galaxy in the future. Given the vast distances between stars, it is unlikely that stellar collisions will occur during the merger. However, the gravitational forces at play could disrupt the orbits of stars, potentially altering the path of our Sun. Such a shift could have profound effects on Earth's climate, pushing it either closer to or farther from the Sun, leading to significant changes in 6 minutes and 39 seconds. Temperature. If the Earth were to move closer to the Sun, it could become hotter, causing ice caps to melt and sea levels to rise. Conversely, if it were to move farther away, a new ice age could begin. These changes could also disrupt the amount of radiation reaching Earth, making it more difficult for life to survive. The merging of Andromeda and the Milky Way, along with the changes it brings, highlights the complex interactions between celestial bodies. Over time, the black holes in both galaxies might move closer to each. 7 minutes and 13 seconds. Increasing the amount of high-energy particles reaching Earth, potentially leading to a rise in cosmic radiation. This increased radiation could harm Earth's ecosystems and influence the course of human evolution. Despite these dramatic changes, the merger will have a lasting impact on Earth's natural orbit and rotation, possibly altering settlement patterns across the planet. Environmental changes, shifts in biodiversity, and ecosystem structures are already occurring globally as climate zones shift. Certain species may adapt while others face extinction. Furthermore, as gas clouds from the merging galaxies combine and form new stars, the radiation emitted from these young stars could significantly alter the environment. This could have a major impact on Earth's temperature and the global ecosystem. These cosmic events play a crucial role in the evolution of the universe, but understanding what happens during them is equally important. The events surrounding the Andromeda collision, which will occur billions of years from now, will likely be beyond the scope of human experience. It is possible that humanity will have relocated to a new home, either somewhere else on Earth or even beyond our planet. Studying the Andromeda Galaxy is vital to understanding how our own universe has changed over time and what its future holds. The differences between Andromeda and the Milky Way help refine our models of how galaxies evolve and interact. Redefining Andromeda's size and mass is a significant step as it helps us learn more about the Milky Way and its structure. New data has forced us to reconsider our initial ideas about Andromeda and its role in our galactic neighborhood. 8 minutes and 48 seconds. Contrary to previous beliefs, the Milky Way and Andromeda galaxies are now thought to be about the same size, challenging our understanding of their positions in the cosmic group and their gravitational influence. Currently, the Milky Way appears to be a barred spiral galaxy, but when it interacts with Andromeda, which is likely to happen soon in cosmic terms, its shape could change. Observing Andromeda's development over time helps us understand how large galaxies evolve. By studying where Andromeda is now and predicting where the collision with the Milky Way will occur, astronomers can better understand how star formation rates, gas and dust distribution, and the cores of both galaxies will be affected by the merger. Advances in galactic technology have made it possible to create these models. Expanding our understanding of cosmic evolution through these models, scientists can predict how the merging of Andromeda and the Milky Way will alter the structure of both galaxies. For example, the new galaxy, often referred to as Milkomeda, will likely have an irregular shape initially but may stabilize into an elliptical form over time. This transformation will be driven by the redistribution of stars, gas, and dust, as well as the central supermassive black holes combining into an even larger one. The merging process will likely cause intense starburst activity, where gas clouds compress under gravitational forces, triggering rapid star formation. These newly formed stars will illuminate the night skies of the planets within the galaxy, offering an awe-inspiring view for any future civilizations observing the events. 9 minutes and 48 seconds. Scientists are also using the Andromeda-Milky Way collision as a framework to understand similar galactic mergers observed across the universe. This knowledge helps astronomers piece together the cosmic history and determine how galaxies form, evolve, and interact on a grand scale. By examining Andromeda, researchers gain valuable insights into the processes shaping our universe. One key focus is the role of supermassive black holes in galactic evolution. When the black holes at the centers of Andromeda and the Milky Way merge, they will release gravitational waves, ripples in spacetime. Observing these waves will provide direct evidence of how massive cosmic events unfold and offer new perspectives on Einstein's theory of general relativity. 10 minutes and 18 seconds. Despite the inevitability of this cosmic collision, it is important to note that the distances between stars are so vast that direct collisions between stars are unlikely. However, the gravitational interactions could significantly disrupt existing planetary systems. For example, the Sun's position within the galaxy could shift, possibly ejecting the solar system into intergalactic space or pulling it closer to the galactic center. If Earth remains within the newly formed galaxy, the increased radiation from starbursts and the combined activity of the supermassive black holes could have profound effects on the planet's climate and habitability. Understanding these risks and possibilities helps researchers consider the long-term future of humanity and life as we know it. 10 minutes and 48 seconds. As technological advancements continue, the ability to study Andromeda in greater detail will improve. Instruments like the James Webb Space Telescope and future observatories will help scientists gather data on the galaxy's chemical composition, star formation rates, and dark matter distribution. This knowledge not only deepens our understanding of Andromeda but also informs broader questions about the origins and destiny of the universe. The study of Andromeda is a testament to humanity's enduring curiosity and drive to explore the cosmos. As we learn more about our galactic neighbor, we uncover clues about the forces that shape galaxies and the interconnected nature of the universe. The story of Andromeda and its eventual merger with the Milky Way highlights the dynamic and ever-changing nature of the cosmos, reminding us of our place in this vast and mysterious expanse.